Hello, everyone. We're looking at lesson 28, titled Advanced Nomenclature. So you'll want to open up, you'll find this in support materials, this polyatomic ion chart. You'll want to open up the periodic table, which is right next to it. And then I have the lesson 28 slides open. You might want those open as well. All right, so what we're going to do, begin with polyatomic ions. And the way that polyatomic ions work, you're going to be using this chart that lists your polyatomic ions. There is a system to this, so I'm going to discuss a bit of that system with you. So an anion is what we call a polyatomic ion that has an oxygen and another element. And with these anions, so if you look, a lot of what you see have an oxygen in there, right? It's a bromine plus an oxygen, a chlorine plus an oxygen, so on and so forth. With these, you'll notice that there's a system. And what the system is, you don't have to necessarily memorize this system. It'll just help you to make sense of what's going on there. Is that if you have two different oxyanions, the one with more oxygens ends in 8, and the one with fewer ends in 8. So an example of that, if you look at sulfur, you have sulfur with 4 oxygens and sulfur with 3 oxygens. So the one with 4 is 8, the one with 3 is 8. So if there's two versions of a polyatomic ion, the one with more oxygens gets the ending 8. The one with fewer will have the ending 8. That's how you tell them apart. But then look right here where we have 4. You'll notice you have, for the bromate or bromite, there's two versions of bromate, two versions of bromite, because there's 4 possible oxyanions with bromine. And so with that, the system is the one with you'll start with 8, and the one with the most begins with a per, ends with 8. And then the one that ends in 8. And then out of the two that have the fewest amount of oxygens, they're 8 and 8. But the absolute fewest begins with hypo. So look at what you have here. You have per bromate, that has the most oxygens. Then bromate will have 3 oxygens. Then bromite has 2. Then hypobromite has 1. It's not that per bromate tells you that per and 8 tells you 4. It just means that out of the 4 options, per 8 will have the most. 8 has the second most. 8 has the third. Hypo 8 has the least amount. So, okay, so if you look like right here, if you compare sulfur, sulfite, and sulfate, but then with chlorine, perchlorate, chlorate, chlorite, hypochlorite. Once again, this is not the main thing you need to understand, but this just helps. So what you're going to do whenever you name polyatomic ionic compounds, you name the positive ion first and then the negative ion. And these things can either come from here or they can come from here. So look at Na2SO4. And once again, it's ionic, so you're not going to have to use your prefixes. So Na2SO4. What is Na? You look right here. Sodium. What is SO4? You look right here. Sulfate. So Na2SO4, sodium sulfate. KOH. K, you look right here. Potassium. OH, you look right here. Hydroxide. We call that potassium hydroxide. Ba, ClO3 2. So there's 2 of these ClO3s. Let's see what this is called. So we have Ba, which is barium, right here. Right there, barium. And then we have ClO3. Here's the Cl's. O3 is chlorate, so barium chlorate. And you'll notice, why are there 2 chlorates? The reason is Ba is in row 2, which gives it a +2 charge. And then you'll notice for chlorate, it has a -1 charge. That's why there's going to be 2 chlorates to balance out the barium. So this is what we use for the first set of questions. And then the next set, we're going to do something called an oxidation state. With this, what you're going to do, you're going to have metals, typically down in here, these transition metals, that can have multiple charges. So what you're going to do is you're going to make a Roman numeral, and you're going to place the charge as a Roman numeral in a parenthesis next to the element. So, for example, if I have mercury 1 iodide, that means that the mercury has a charge of just 1. In fact, let me fix this. So if you have mercury 1 iodide, then what you'll see is that the mercury Hg is only going to have a +1. So Hg has a +1. Not because of where it's at on the table, but because it uses the stock system, meaning this right here tells you your charge. And then iodine right here is a -1, so they balance out 1 and 1. Or what it had before, 2 and 2, which is a different situation. And look right here, Hgi2. Well, that's happening because it's mercury 2, meaning the mercury has a +2 charge, iodine has a -1, so it requires 2 iodines to balance it out. So that's how we do the stock system. So you'll see this set of questions. You'll see the elements, and you have the stock system right there. And then the last thing we have on this lesson is something called a hydrate, which will either be one of these ionic compounds in the stock system or one of these polyatomic compounds. And with a hydrate, what you're going to do is you just use everything we've learned to name it, but because you have a large complex structure, a water sometimes gets held on it. So what you do is you have a dot, and then it has a water molecule after the dot. So for example, it looks like these. It's these right here, where you have the whole compound and then a dot and then water molecules. But what you'll do is you'll name the element, and then you'll use a Greek prefix and say hydrate to say how many waters are attached to it. So look right here, Na2CO3. Look up Na, it's sodium, CO3 is carbonate, so this is sodium carbonate. But if it's got a dot H2O, it's bonded to 1 water, so you say sodium carbonate mono for 1 hydrate. Or this one, this is bonded to 7 waters, so sodium carbonate heptahydrate. So that's how we go about naming hydrates. All right, so we have polyatomic, we have stock system, and we have hydrates. So you can go back and look through the slide if you need to, but I want you to press pause. I want you to try all of these and then press play, and I'll go through them with you. So press pause, try all these problems, and then press play, and I'll go over it. Okay, KNO3. If you need to, you can look right here to see NO3 is nitrate. So that'll be potassium nitrate. NH4NO3. That'll be, if you look right here, NH4 is one of the weird positive polyatomic ions we have. So NH4NO3 will be ammonium nitrate. NaNO2, look at what NO2 is. It's not nitrate, it's nitrite. So NaNO2 will be sodium nitrite. Ba3PO4. Why are there 3 and why are there... Well, this is because barium has a +2 charge, and this phosphate has a -3 charge. That's why it takes 3 and 2 to balance it out. So when up with barium phosphate, you have it down there. NH4, remember, is called ammonium with a +1 charge, so it takes 2 of them to balance out the -2 charge that we get from sulfur. Since sulfur is ending it, you have to end it with an ide. So ammonium sulfide. And then CaC2H3O2. You look at this, you're like, what in the world is this? That is the longest out of the ones we have on our chart. And it's right here, acetate, C2H3O2, and it has a -1 charge, which is why it takes 2 of them to balance out of calcium. So you have calcium acetate. All right. Now we use stock system. So first, this one right here is lead chloride. But what kind of lead? It took 3 chlorines to balance it out. If you remember on the periodic table, chlorine is right here with a -1 charge. So our answer here will be lead 3 chloride. Lead 3 chloride. Then we have mercury sulfide. If it takes 2 mercuries, mercury must have a +1 charge. Because sulfur has a -2 charge. It took 2 of our mercuries. They each must be +1. So we should have mercury 1 sulfide. Cobalt sulfide, once again, if it took 2 cobalts. Oh, look, the cobalt, you need 2 sulfurs to balance out the cobalt. So it should be cobalt. This is actually typo. I'm going to fix this by the time you do this. Since there's 2 sulfurs, it should say cobalt 4 sulfide, which 4 will be an IV in the Roman numeral. So this should say cobalt 4 sulfide because there's 2 sulfurs, each carrying a -2 charge. FeOH3, this is an iron and a hydroxide. If there's 3 hydroxides, they have a -1 charge, so you need 3 irons. So that should be iron 3 hydroxide. Lead chromate. Chromate has a -2 charge, so it must be lead 2 chromate to balance it. And then SN is tin, and there's 2 acetates, and each acetate has a -1 charge. So tin 2 acetate. Okay, and then lastly, we're going to use a combination of our systems and then say how many hydrates it has. So this should be calcium sulfate dihydrate. Oh, I said, yeah, I'm right. Calcium sulfate dihydrate. And then we have magnesium sulfate and 7 heptahydrate. Magnesium sulfate heptahydrate. Na2SO4, 10H2. So this is sodium sulfate, and then 10 is decahydrate. So, oh, you know what? Did I miss a detail on this? It says sulfite. Oh, no. Okay, yeah, I'm on the right track with that. I was looking right here thinking it needed to be sulfite for this right here. But no, it's this right here. Sodium sulfate decahydrate. Yeah, sodium sulfate decahydrate. Right here, it's nickel. If it's bonded to a sulfate, it must have had a +2 charge. So it's nickel 2 sulfate and then hexahydrate. Sodium, and then look right here, it's got a 3, not a 4. And if you go back and look at this, when it has 3, it's called sulfite on the oxygens. So this will be sodium sulfite, 5 is penta. So sodium sulfite pentahydrate. And then last but not least, iron. What kind of iron? It must be iron 2, since it's bonded to a sulfate. So iron 2 sulfate heptahydrate. So iron 2 sulfate heptahydrate. So I will make sure to fix the mistake that we had on here where this needs to be a 4. By the time you do this, that'll be a 4. All right, so as always, email me if you have any questions or any issues.